The scientific process or scientific method consists of four major activities from an academic standpoint of teaching and learning. The first is always gaining empirical knowledge of nature using the tool of making casual or experimental or accidental observation. Empirical means pertaining to observation. No speculation is allowed here. The result is an isolated fact whose reproducibility is constantly checked before accepting it as established and including it in books and textbooks. The casual observations such as burning of wood, rusting of iron, exposed flesh of an apple turning brown, and milk turning sour led to the branch of chemistry and the coining of the term chemical change. The isolated fact may be qualitative, such as hydrogen and oxygen combine together and produce water, or quantitative, such as 2.016 gram hydrogen combines with 16.00 gram oxygen and produces 18.016 gram water. A qualitative fact does not contain any number at all, whereas a quantitative one contains at least one number in its statement. The second major activity is generalizing isolated facts. The first tool is comparing and contrasting related facts on some or other basis. The result is an empirical classification, such as physical classification of matter into solids, liquids, and gases, which uses size and shape as the basis, and chemical classification of matter into elements, compounds, and mixtures, which uses separability, identity, and composition as the basis. The second tool is analyzing experimental data and recognizing a numerical pattern which indicates that nature follows a rule in its behavior. The result is a law, such as the law of constant composition of compounds, Boyle's law, and rate law. The mathematical equation of the law reveals the numerical pattern recognized in the experimental data. The empirical classifications, laws, and yet unorganized isolated facts constitute the empirical knowledge. The third major activity is making sense of, understanding, and hence explaining empirical knowledge. The tool is to speculate on the invisible and observable aspects of nature with the help of inductive logic. The initial result is hypothesis, which is a collection of postulates or assumptions. Yet unknown facts are predicted in thought experiments using the hypothesis with the help of deductive logic. The predictions are verified by performing those experiments. If the hypothesis continues to be successful over an arbitrarily long period of time in explaining known facts and predicting unknown facts, it is elevated in status to theory such as atomic theory and quantum theory. A theory is not the final say, and the process of prediction, etc., is continued with theory also. Thus, there is a constant interaction and interplay between facts and postulates. The postulates and theories constitute the theoretical knowledge. The explanations of facts serve as the bridge between empirical and theoretical knowledge. The fourth and last major activity is describing empirical and theoretical knowledge both precisely and concisely. This activity pervades through all the previous activities and is carried out as and when needed. The first tool is to invent precise language, and the result is a special term such as matter, molecule, and internal energy. The second is to construct a concise way of communication, and the result is a special representation such as symbol, formula, chemical equation, electron configuration, and molecular structure. Because a detailed information is compressed in the form of a special representation, certain rules are formulated to make sure of uniform and correct communication. For many more details on the scientific process and the various misconceptions prevalent, watch my video series containing 5 parts. Also, see my book, Understanding Chemistry.